Hello, wonderful people. This is Mr. Manson, and this is help with assignment number 4. We're going to look at the last topic we looked at before we left school was solving basic exponential equations. And for this assignment, we are going to look at numbers 1 through 18. This is what you'll submit to me for your next assignment. So when solving exponential equations, it is important that we remember that the big number is called the base, and the little number is called the exponent. And when you have a base equaling another base, you can just simply cross off the bases and set the exponents equal to each other. And that's the whole point. And then you solve this equation for whatever this situation is. So here's a quick example that shows this. Suppose I had 2 to the x and it equaled the number 16. Now 16 has its own exponent of 1. Here the bases are 2 and 16. Here the exponents are x and 1. Since 2 and 16 are the bases and they don't equal each other, what we need to do is figure out how can we make them equal. Well, we know a fact. One fact is that if I took the number 2 and we raised it to the 4th power, we should know that that gives us the number 16, just like that. So what I do is I take 2 to the x, I ignore the 1 is here for the exponent, it's not even there, and then I just simply rewrite 16 to be 2 to the 4th. That way now, the 2's match, which they're the same bases like the b's, so the 2's just simply cancel. And you set the exponents equal to each other. So in this case, x equals 4. So let's take a look at the assignment here that we're doing. The directions say, once the bases are the same, set the exponents equal to each other and then simply solve for x. So in number 1 here, it shows that the bases are equal to each other. So I simply cross off the bases, and then I set 2 equals to x. Since that's already solved for x, I circle that, and I'm done with that particular question. 1 through 4 is done the same way. If you look at number 4, let's do this one together. This one here, can you tell what the bases are? If you look at the bases of 2 6's, you can simply see that they match and you can cross them off. Then you set the exponents equal to each other. Then what you remember from your Algebra 1 skills is how do you solve for x. If you have x's on either side, you want to bring the less over to the greater. There's 3 here and there's 4 here. So let's take these 3 and subtract it on both sides. That way these opposites cancel. 4x take away 3x becomes x. Bring over the equal sign and then bring down the 5. So the answer is x equals 5. That is already done for you there. So again, if the bases are the same, you simply cross off the bases and then set them equal to each other. Well, what if they weren't the same number? So let's take a look at like number 6. This one says 2 to the x equals 8. Well, if I rewrite 2 to the x equals, I know 2 and 8 are bases. They don't equal each other unless I write 8 to be 2 to the 3rd, because 2 times 2 times 2 would give us 8. And that's what that equals. So now the bases equal each other. You can see that x equals 3, just like that. Looking at number 7, this one here says now it's 2 to the 2x equals 8. Nothing changes except it says 2x here. So I write 2 to the 2x equals, and I change 8 again to be 2 to the 3, just like that. Now the 2's cancel, and I set the exponents equal to each other. 2x equals 3, and now solve this for x. So to do that, it's 2 times x. You do the opposite, which is division. These 2's cancel, and then you have x equals 3 halves, or 1.5, or 1 1/2, however you want to put that. And so just don't be fooled if they add extra things. All you just remember is make the bases the same, cancel them off, and set the exponents equal to each other. And just remember what you did back in Algebra 1. Let's jump down to ones that are a little bit more tricky. Let's try number 11 here. 11 looks like it could be a little bit of trouble here. Let's see. The bases are 27 and 3, so let's make them the same. So you have to know that 27 is 3 to the 3x. And here I just write this as 3 to the 4x minus 8. Just copy that. Now the 3's match. You put the 3 here, that was the exponent to this base of 3, it goes next to the x as a multiple. So that when these 3's cancel, I come off to the side here and I say 3x equals 4x minus 8. And then I try to solve this over here. Oh, here we are. Over here we try to solve that for x. So I would do this by subtracting 3x on both sides, little to the big. Those cancel, and I have 0 equals 4x take away 3x is x minus 8. Then I move the 8 over to get x by itself by adding 8 to both sides. The 8's cancel, 0 plus 8 is 8 equals this x here. And so we get x equals 8 for that problem. Let's do a couple more together here. Let's take a look at number 13. This one here, 25 to the 2x equals 5 to the 4th. I would change 25 to be 5 squared to the 2x, and 5 to the 4th, leave that as 5 to the 4th. So you just have to know that 25 is 5 squared. Now the 5's cancel. Multiply these numbers. 2 times 2x, that will give us 4x equals 4. Then you simply divide both sides by 4. 4's cancel. X equals 4 over 4 will give us 1, just like that. And let's do one more on here. I think 18 is sort of a thinker stinker here. I'm gonna let you think about 18, but I'll give you a hint. The hint here is base of 2 twice. So think about what this means with the 16 and the 8. Let's take a look at 17 here. Let's do this one and then I'll let you get started on this assignment. 2 and 8, well, different bases, so let's make 8 2 to the 3rd. So you'd write it like this. 2 to the 2x minus 4 equals 2 to the 3 to the x plus 3, just like that. So what you have to do is put parentheses here because this new exponent of 3 will be distributed next. So these 2's cancel, and a little bit out of space here. Let's squeeze this in. So I get 2x minus 4 equals 3x plus 9 after I distribute the 3 to both of those. Now solve for x. I subtract 2x on both sides, and at the same time we can subtract 9 on both sides. So 2x's cancel, the 9's cancel. Negative 4 and negative 9 add up to be negative 13, and 3x minus 2x is x. And that brings us to our answer is negative 13. That's more of a challenge one for that one. So good luck and keep on doing the wonderful, great work that you're doing. Take care.